Well, we finished a chapter. I hope you're starting to get the groove of things. We're starting to see how things go. And I just want to say, don't forget, we are always available. You can contact Mr. Jordan in the mornings or contact me at around lunchtime, or either one of us can make appointments later on. We can also meet before and after school. So please, 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 if you're struggling with anything, don't let yourself get behind. Ask. So chapter 1 was really about reviewing some concepts that we need for Algebra 1. Chapter 2, we begin looking at lines. And we're going to continue looking at lines and how lines behave and what we can know about lines for a little while this semester. So the first thing we're going to do is we're going to start in an area that hopefully you're a little bit familiar with, and that's slope-intercept form. So our objectives for today are number 1, to be able to graph lines that are written in slope-intercept form. And number 2, to be able to write equations of lines if I give you points, if I give you graphs, or other information. So let's review. What is slope-intercept form? You can see it written here on your screen. Y equals mx plus b. You know, mathematicians aren't really very creative sometimes, and so slope-intercept form is called slope-intercept form because they give you those two pieces of information with slope-intercept form. They give you the slope, and they give you the y-intercept. So let's talk about those two things. What is a slope? You know, some people say slope is the steepness of a line. That is correct. Some people may even say the slope is the rise over the run. You've probably heard that spoken before. That is also correct. The letter that represents slope in this equation is the m. And the slope tells us how to move. The slope tells us how much to rise and how much to run. In other words, the steepness of our line. So what is the y-intercept? Well, the y-intercept is where our line crosses the y-axis. In other words, where it intercepts the y-axis. In our equation, it's shown by the letter b. This isn't really what it means, but it helps me remember. It tells me where to begin my line. So I always begin my line at the letter B. A couple other things that I just want to remind you of to help us with graphing. If I have a positive slope, so if my m is positive, I know my line is going to be going up and to the right. And if my slope is negative, I know my line is going to be going down and to the right. So what does this look like? Well, let's say I have an equation written as y equals 2/3 x minus 4. So we always begin at the y-intercept, which is the b, and in this case, that's a -4. And so what that tells me is on my graph, I will come to the y-axis, which is the one that's going vertically, and I'll come to the -4. And I'll plot a point because I know my line is going to cross the y-axis at that -4. Then I come over to the slope, and remember the top number tells me how much to rise, the bottom number tells me how much to run. So because everything is positive, I'm going to go from my point at -4, I'm going to rise, sorry about that, I'm going to rise to, and run or go to the right 3. And then once I have those 2 points, I can do it multiple times if I want, or 2 points is enough for me to draw a line. Let me ask you one more question. What if my slope looks more like this? Y is equal to 3x minus, we'll say, plus 4. So this time, I'm going to start at +4, but how do I know how much to rise and run? Well, guys, when we're given a whole number, we can divide by 1 because 3 divided by 1 is still just 3. And so then from there, I can rise 3 and run 1 and get that line. So let's try one on your own. Can you do a quick sketch of a graph of y equals 4/5 x plus 2? So we would start at positive 2 because that's our y-intercept, and then 4/5 says to rise 4, 1, 2, 3, 4, and run 5. 1, 2, 3, 4, 5. Now, just so that we're all clear, sometimes our graph is drawn so that it's hard to do a rise 4, run 5. So I want you to understand it would also be appropriate for me to go down 4. But if I go down 4, I need to go to the left 5 because I want to keep that slope being a positive slope. And so I just need to think about what direction a positive slope would go, this direction. And so once I know that, then I can determine if I go up, I need to go to the right, and if I go down, I need to go to the left. Try this one. So y-intercept is at -5. And then my slope is negative this time. So I know I want my slope to come down this direction. And so if I know I want it to come this direction, I choose to go down 3 and still to the right 4. Most of the time when I see a negative, I choose to go down. And when I see a positive, I choose to go up. And I always go to the right. But again, if I wasn't sure about it, or if I was out of space, I could always go up 3 and to the left 4. And then draw my line there. I hope that is a good reminder for you, that you've seen that before and feel comfortable with that. The next thing then that we're going to look at is really just the opposite. What if I give you the graph and ask you to write the equation? So, thinking again about the name of this form, slope and intercept, those are the two pieces of information we need to pull from a graph in order to be able to write our equation. So, one of them, or both of them, are fairly easy to do. The y-intercept is where the line crosses the y-axis, so I can see that right here. That looks like it crosses at a positive 1. The slope is a little bit harder. We have to do a little bit more thinking. Guys, in order to find the slope, we need to count the rise and the run. So we need to find 2 points on the graph that cross at nice corners of boxes so that we're able to count accurately. So I'm going to start here with the y-intercept, and then I'm just looking on that line for another point that crosses at a corner of a box, and I see one down here. So now I'm going to count the difference between, I'm going to count the rise and the run. So from this point to this point, it looks like I had to go down 1, 2, 3, and I had to go to the right 1, 2, 3, 4. So because I went down 3 and to the right 4, my slope would be -3/4. So now that I know those two pieces of information, I'm ready to write my equation. Y is equal to -3/4 x plus 1. Again, beginning at the y-intercept of 1 and then following that slope, moving by going down 3 over 1. Why don't you try this one on your own? So I hope you found that the y-intercept was at -2. And then counting the slope, it looks like we went up 2 over 1, 2, 3. So that would make my slope 2/3. So my equation should be y is equal to 2/3 x minus 2. So I hope that's a good review of how to graph when an equation is given in slope-intercept form, and how to write an equation in slope-intercept form when you're given a graph. Now let's look at a couple other things that we might be given. Look at this question and just consider, how would the graphs of 2x plus 1 and y equals negative 2x plus 1, how would they be similar? And how would they be different? I hope you recognize that they both have the same y-intercept, which is 1. I think that you could also say they have the same steepness. They don't have the same slope, but they have the same steepness. One just goes in the positive direction and one goes in the negative direction. So how are they different? They move in different directions. So if I were to graph these, it would look like this. The first one would begin at 1, and then it would rise to run 1. So it would look like this. The second one would also start at 1, but it would go down 2 and to the right 1. So it would look like this. Those two lines would intersect at the 1, and they would be the same steepness, just one is going in a positive direction, the other is going in a negative direction. All right, let's take a look at this one. How can I find an equation of a line that passes through 2 points if neither of them is the y-intercept? So they're asking us to consider the points, a line that goes through the points -1, -2, and 3, 4. So just because I want to get a clear picture of what they're asking, I'm going to go ahead and plot those 2 points, plot this line, and see if that gives me any hints for how to find this. So looking at this, I'm starting with the point -1, -2, and then the point 3, 4. So here's my line. Now I'm just drawing a sketch, so I'm not sure that I would trust my line in order to be able to find the y-intercept. But looking at that, I can tell that where the y-intercept is close. It's close to that 0, 1 area. I don't know, I might have drawn it even a little high, so it may even be in the negatives, but it's close there to that 0. But in order for me to write an equation in slope-intercept form, I need to know 2 things. I need to know the slope, and I need to know the y-intercept. Neither of those things are completely clear from my graph. Now, I could find my slope by counting from point to point. So I could count and go 1, 2, 3, 4, 5, 6, and then over 1, 2, 3, 4. So I could find that my slope is +6 over 4. But I want to introduce another way that we can find slope without drawing a graph, and that's using this slope formula. I know this formula may look a little scary because what are those 2's and those 1's, and they're not exponents, they're called subscripts, and what does all of that mean? Guys, it simply means take the y value from point number 2 minus the y value from point number 1 and divide it by the x value from point 2 minus the x value of point 1. It really doesn't matter which point we call point 1 and point 2, we just need to be consistent. So if you'll remember, in an ordered pair, the x value comes first and then the y. Over here, the x value comes first and then the y. So if I'm going to find slope using my slope formula, I would take the y value of 4 minus the y value of -2. Then coming back to the original, I would say 3 for the x value minus -1. Minus negative becomes plus positive. Minus negative down here also becomes plus positive. So 4 plus 2 is 6, and 3 plus 1 is 4. You can see that I found the same slope. The slope formula is nice if you don't want to graph, or if your points are so big that it would be hard to graph those points. Again, let me just show you it doesn't matter which point you use. So we could also do -2 minus 4 over -1 minus 3. And in doing that, I end up with -6 over -4. But the negatives cancel out, so I still end up with that same slope of 6/4. All right, so once I know the slope, I still have to find the y-intercept. And although I could make a guess looking at my graph, unless I'm really, really accurate, that's not the best way. And so what I'm going to do is I'm going to write my equation, y equals mx plus b, and I'm going to plug in some values that I know. So first thing, we found that the slope was 6/4. And I can absolutely use 6/4, but I'm noticing that that can be reduced by 2. So 2 goes into 6 3 times, and 2 goes into 4 2 times. So now I have the slope in its place. And then I don't know what my x and y are, but I have 2 opportunities here for what x and y could be, because these points are on the line. And so I'm going to choose to use 3, 4, and I'm going to put the 4 in the y position, and I'm going to put the 3 in the x position. And that leaves only one variable of b. And so now I'm just solving an equation trying to figure out what b could be. So I end up with 4 is equal to, simplifying, 3 halves times 3 gives me 9 halves plus b. To solve that, I'm going to subtract 9 halves from each side. And when I do that, I end up with -0.5. And so anytime I do some work, I want to see, does that seem reasonable? So coming over here to my graph, is it reasonable that my line might be coming over here through a -0.5? And although the first line that I drew seemed a little higher than that, remember, I was just sketching a line on a computer screen. So I do think that -0.5 seems reasonable. Had I gotten an answer like 10 or -10 or something like that, that may have caused some pause for me, thinking that that's not quite correct. All right, so now I know my slope and my y-intercept, so I'm going to write y is equal to 3 halves x and then minus 0.5. You could also write that as -1/2. So this one took a little bit more work, but we were able to find the slope and the y-intercept. So why don't you take a minute and try this one on your own? So step 1, I need to find slope. So I'm going to take y minus y divided by x minus x. One thing that helps me remember slope formula is it's wise to put the y's on top. And so I'm going to start by taking that 6 minus 4 over -1 minus 5. Again, if you chose to do 4 minus 6, as long as you did 5 minus a -1, totally fine. So 5 minus 4 would be 2, and -1 minus 5 would be -6. I'm going to reduce that fraction just to work with smaller numbers, and I get -1/3. So there's my slope. And now I'm going to choose one of my 2 points. Again, it makes no difference what point you choose. However, I like to stay positive if possible, so I'm going to choose the 5, 4, and then I'm going to plug those values in to my equation y equals mx plus b. So I'm plugging the y value of 4 into the y position, the slope of -1/3 into the m or slope position, and the 5 into the x position. I don't know b, so that I'm leaving that one as a variable. Now I'm solving an equation. -1/3 times 5 is -5/3. I still have the 4 over here plus b. And so at this point now, I'm going to add 5/3 to each side. So I'm going to end up with 4 plus 5/3, and I end up with 5 2/3 as a solution, which means it's going to cross my line at 5 2/3. So now that I know my b, and I also know my m, I'm ready to write my equation. Y is equal to -1/3 x plus 5 2/3. And guys, if I really wanted to check my answer to see if I was correct, I absolutely could do two things. Number one, I could graph the 2 points. So over 5, up 4, and -1, 6. And then I could check that with the equation that I wrote. So does it seem reasonable that it would go through 5 2/3? So if I count 1, 2, 3, 4, 5, yes, that seems reasonable because my line goes through somewhere between 5 and 6. And then from that point, if I went down 1 over 3, does that also seem reasonable to be on my line? And I would say yes, it does. So I can feel comfortable with the line that I've drawn. All right, so now you're going to be doing some practicing on your own, both with graphing and writing in equations. You're going to be looking at Pearson 2.1. If you've got any questions, don't hesitate to email Mr. Jordan or myself, and we will get back with you just as soon as we can. If we need to, we'll set up a meeting either in person or online. I hope you have a great day, and we'll talk to you later.